Okay, today's topic is comes from 2.1 quadratic functions. What we'll be doing is graphing, writing equations, and finding the minimum and maximum values of quadratic functions. Okay. First of all, what we called and what we've always seen in our Algebra 2 books is that the function is of this form, ax squared, so to the second power. All right, let's look at a couple graphs and examples. What we want to do is describe the transformation. So let's do that first. My transformation, this number tells me it's going to be a stretch, okay, by 3. Now we're going to sketch the graph. So what we want to do is we know it's a parabola. And since the vertex has not shifted left or right, we know that the vertex is going to be at 0. And 0. This is just a stretch. So it hasn't shifted to the left or the right. Now, what I want to do is do a T-chart. Okay, 2 less than the vertex and 2 greater than the vertex. Now I'm just going to simply substitute into my function, which will be 3x squared. So I'm inputting x, and this is my y, equal 3x squared. When I substitute negative 2 in, it's 4 times 3, 12, 1 times 3, 3, 1 times 3, 3, 4 times 3, 12. We should have a reflection in our T-chart. So let's plot those points. 0, negative 1, 3, negative 2, 12 is way up here somewhere. Same thing on this side. So our parent function, which is this, our parent function right here, this is y equal x squared. 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4. That's our parent function. Notice it's been stretched. Okay, the outputs get bigger, so the graph gets skinnier. What's my domain? My domain would be all real numbers, because I can put in any x value. However, my range, there's a low point in this one. My y's are not any less than that, so everything, my graph is going up, so my y's in my range are going to be greater than or equal to 0. Describe the transformation again. So this time, we're going to have a reflection, and we're going to shift up 1. Okay, so this time, our graph will be shifting 1. Our vertex is going to shift up 1. It doesn't change the h and k, so the h or the x stays at 0, but it shifts up 1. It's also going to be reflected, but we'll do that math in just a second. Again, 2 less than the vertex and 2 greater than the vertex. All right, now we do straight substitution. Negative 2 squared is 4. 4 times negative 1. Negative 2 squared, so it's a negative 1 times a negative 2 squared plus 1. All right, and that will end up being negative 3. Now I do the same thing with negative 1. Substitute it in. I will get 0. When I substitute 1 in, also going to get 0. And then when I substitute 2, I'm going to get 3. All right, so let's look at this graph. So negative 2, negative 3, negative 1, 0, 0, 1, 1, 0, and 2, negative 3. So we have a reflection. It turned upside down, and we have a vertex that shifted from 0, 0, up 1. Remember our parent graph? So that was our parent graph. All right, so it reflected, and so it turned upside down, and then the vertex shifted up 1. So look at our domain. Again, our domain could be all real numbers, because I can put in any x value. But my range this time, since it's opening down, it's going to be, y's are going to be less than or equal to the y value of my vertex, which is 1. Next one, again, describe the transformation. So our transformation is going to shift left 2 and down 3. So if I look at my vertex shift, it's going to go to -2, -3. All right, so now I'm going to choose points to less than and to greater than my vertex point. And then I'm going to substitute it in. So if I substitute -4 in, that would equal 1. Now when I substitute -3, I'm going to get -2. When I substitute -1, I get -2. And when I substitute 0, we get 1. All right, so now, again, so let's look at this graph. -4, 1, -3, -2, -2, -3, -1, -2, and 0, 1. Okay, so that's our graph. Now what's our parent graph? Our parent graph was here. So if you notice, every point on our parent graph shifted left 2 and down 3. Left. Okay. So from our parent graph, we went 1, 2, down 1, 2, 3. So everything shifted left 2, down 3. Look at our domain. Again, it's going to be all real numbers because I can put in any x value. My range, it's opening up, so my y's have to be greater than or equal to what's my lowest y point. My lowest y point is -3. Standard form of a quadratic, also known as vertex form. This is what our pre-calc textbook calls standard form. This is what almost every other textbook calls it, but that's what we saw in Algebra 2. F of x equal a times x minus h quantity squared plus k, but a doesn't equal 0, because if a equals 0, then we have a linear function. The vertex is hk. Axis of symmetry, x equal h. Remember, on our graphs, if we go back to our graphs, they're reflective over the vertex. If a greater than 0, there's a minimum. In other words, it opens up. If a is less than 0, has a maximum, which means it opens down. So let's look at an example. if my f of x is equal to a negative 2 times the quantity x plus 5 squared plus 4, what is the vertex of the graph? The vertex of the graph is our hk. Does the graph have a minimum or a maximum or a minimum? We know that it's going to open down. We know that it opens down, so it's going to have a maximum. Now, what is its maximum value? The maximum value is k. Maximum value is 4. The other way to look at that, look at this, for your maximum minimum value, also consider the y-coordinate of the vertex. All right, so sketch a graph of the quadratic function, identify the vertex and x-intercepts. Well, we don't have an h, and we don't have an h, so that's 0. Our k is negative 7. So our vertex is going to be at 0, negative 7. Our line of symmetry, remember, runs through the vertex. All right, so now, t-chart. Our center point, 0, negative 7, 2 less, 2 greater. Now let's go ahead and do the math. So when I plug in negative 2 squared, it's 4, 4 minus 7, negative 3. Negative 1 squared, 1 minus 7, negative 6, and so on. And so now I have my t-chart. So let's sketch the graph. That's what we're doing first. Negative 2, negative 3, negative 1, negative 6, 1, negative 6, 2, negative 3. Okay, so let's talk about domain and range. We've checked off the vertex, we sketched it. The domain of this graph will be all real numbers. My range will be y greater than or equal, my lowest y point, negative 7. Okay, now finding the x-intercepts. X-intercepts is where it crosses the x-axis. Where it crosses the x-axis. So that means f of x has to equal 0. So what I do is I solve the equation. I say 0 equal x squared minus 7. So 7 equal x squared. X equals, take the square root of both sides, plus or minus square root of 7. Now that's what x equals. That's a solution. So my y-intercepts, or my x-intercepts, excuse me, my x-intercepts when y is equal to 0, and my x, in this case, plus or minus 7, 0. All right, let's look at this one. We're going to sketch the graph. Let's identify the vertex first. We have an h and k in this case. So my vertex is at 1, 3. Let's do a t-chart now. Vertex at 1, 3. 2 points less and 2 points bigger. Okay. So now, when I plug in negative 1, that would be negative 2 squared, 4 plus 3, 7. When I plug in 0, negative 1 squared plus 3, 4. And I do the math with the other ones, just to make sure that they're a reflection over the vertex. Okay, so let's look at let's graph this. -1, 1, 3. Okay, it's my vertex. 0, 4, -1, 7. Then we've got 2, 4, and 3, 7. Okay, so now just looking at the graph, it never crosses the x-axis, so there are no x-intercepts. Our domain of this function would be all real numbers, and our range will be y greater than or equal to 3, the lowest y value. Okay, sketch a graph of the quadratic function. Identify the vertex by putting into vertex form and the x-intercepts. All right, this one's going to take us a little longer. To put it into vertex form, we're going to have to complete the square. So if we complete the square, we end up with x squared plus 2x plus something equal -1 plus something. Remember, if we add things to both sides, we don't change the value. All right, so to complete the square, you take your b value, divide by 2, and square it. So that's 2 divided by 2 is 1, 1 squared is 1. I'm going to add 1 to both sides. This trinomial is a perfect square. So I'm going to factor, and it factors to x plus 1 squared equal to 0. Now, since we already have it equal to 0, we're going to solve to find x-intercepts. So to solve this, what I want to do is take the square root of those sides. X plus 1 equals square root of 0 is 0. X equals -1. So my x-intercept will be -1, 0. In other words, it only has one x-intercept. So now, my function, I've already put it up here. This is my function in vertex form. Okay, so that would be plus 0. So if I identify my vertex is also going to be the same as my y-intercept at -1, 0. So now I do my t-chart. So I'm going to do my t-chart with -1, 0 in the middle. I'm going to choose 2x values less and 2x values greater. Now what do I do? Plug it in. So it's -2 squared, and give me 4. Plug in -2, gives me 1, 1, 4. All right, so let's plot our graph. -1, 0. -2, 1. -3, 4. 0, 1. And 1, 4. And so that is now my parabola. The domain, all real numbers. My range, y is going to be greater than or equal to my lowest y point, which is 0. Okay. Do the same thing for this one. So solve by putting it, okay, we have to put it into vertex form. So we're going to complete the square. So to complete the square, I take my b term, 8 divided by 2 squared, 4 squared is 16, add 16 to both sides. Okay, so this is going to factor to x plus 4 quantity squared, and it's going to equal 5. Now at this point, we're going to solve to find the x-intercepts, just like we did before. This time though, we're going to, when we take the square root of both sides, we have x plus 4 equal plus or minus the square root of 5. So x equal negative 4 plus or minus square root of 5. I subtracted 4 from both sides. So my x-intercepts are negative 4 plus or minus square root of 5, which has a value, if you put it into your calculator, y. Notice there are two x-intercepts, the plus minus. All right, so we put it into vertex form. We have found the x-intercepts. Now my function, though, if I start with this as my solution, okay, as my way of completing the square, it's not in function form. So if I put x plus 4 quantity squared, if I subtract 5 from both sides, I now have it in vertex form. X plus 4 right here equal 5. If I subtract the 5 and move it over there, I now have my function form. I can find my vertex. Negative 4, negative 5. Again, I do my t-chart. I always come back to the t-chart. This would be x plus 4 quantity squared minus 5. What's my vertex? Negative 4, negative 5. X value is lower than, negative 5, negative 6, and greater than, negative 3, negative 2. When I start substituting those in, negative 6, this would be negative 6 plus 4, negative 2 squared, 4 minus 5, that's going to be a negative 1. And so on, I plug in negative 5, negative 3, and negative 2, and I get those output values. So let's graph negative 4, negative 5. Negative 5, negative 4. And negative 6, negative 1. Okay, negative 3, negative 4. Negative 2, negative 6. It is reflected around the axis of symmetry. My domain will be all real numbers. And my range is opening up, so my y's are greater than or equal to my lowest y value, negative 5. All right, so again, we have to put it into vertex form. This time our A is negative, so we know that it's going to have to open down eventually. But we have to put it into vertex form, so we're going to complete the square. So out of this part, I'm going to factor out a negative 2. When I factor out a negative 2, I end up with x squared minus 8x. And then it's going to equal 31. I move this to the other side. Okay. Now, I take this b term, not the original, the one that I factored out. Negative 8 divided by 2 squared, that's negative 4 squared. This would be 16. But what am I really adding to both sides? The negative 32, because I have to distribute that negative 2 in. All right, so I end up with a negative 2 times x minus 4 squared equal negative 1. Okay, so again, we solve this to find our x-intercepts. So I'm going to divide both sides by a negative 2. Square root both sides. Now, To rationalize this denominator, we'll go over more in class, but what you would do is you separate that out as square root of 1 over square root of 2, and you would get plus or minus square root of 2 over 2. We'll talk about this more in class. But then what I'm doing is I'm going to add 4 to both sides. So those are my x-intercepts. It would be 4 plus or minus square root of 2 over 2. 0. Those are my x-intercepts. Let's solve for that. Now, to put it into vertex form, I take this, and I'm going to put it into my vertex form, my function. So f of x equals negative 2 times x minus 4 squared, but the negative 1 was on the right. I'm going to move it back over to the left by adding 1. So now I have it in vertex form. Notice my a in my vertex form is the same as my a in my other form. So let's identify the vertex. The vertex is 4, 4, 1. Now let's go and do our t-chart. Okay, so t-chart. So my vertex is 4, 1. 3 left, 2 less, and 2 greater. Substitute it in. 2 minus 4. Negative 2 squared is 4 times negative 2, negative 8 plus 1, negative 7. Do the same thing with 3. 3 minus 4 is negative 1. Negative 1 squared is 1. 1 times negative 2, negative 2, negative 2 plus 1, negative 1. Same thing with 5 and with 6. Now, let's do our graph. 2, negative 7. 3, negative 1. 4, 1. 5, negative 1. 6, negative 7. Domain, again, will be all real numbers. And my range y, this time it's opening down. So all my y's are less than that point, and that highest y value is 1. Now we're going to write the equation given what we know. Okay, so we're writing the standard form of the equation of the parabola, whose vertex is at 1, 2, and it goes through the point 3, negative 6. So what do we know? We know h equal 1, k equal 2. That's from our vertex. We know that x equal 3 and y equal negative 6. So this is the standard form. So since that's a standard form, we know everything. We know the y, we know the x, we know the h, and we know the k. So let's substitute. Y is negative 6. We do not know a. We know x. Okay, remember it's x minus every time. We know h, 1 squared, and we know k. 3 minus 1 squared, 2. 3 minus 1 is 2. 2 squared, 4. So it's 4 times a plus 2. Now it's a two-step equation. So we're going to subtract 2. And we get a negative 8 equal 4a. A will equal then, divide both sides by 4, negative 2. So now we solve for a. So now we're going to write the equation for all x, y. So for all x, y would be y. What's our a? -2. For all x, then it's minus our h plus our k. Let's do one more. What do we know? We know h is equal to -4. K is equal to 11. X is equal to -6. Y is equal to 15. So we substitute everything we know into our equation. Y equal a times x minus h squared plus k. All right, so what does y equal? 15. We don't know 8. We don't know a. We know x. -6 minus h is -4 plus k plus 11. Let's solve. 15 equal -6 if it's a minus, oh wait, that's squared, minus plus, so -6 plus 4 is a -2 squared, so that's 4a. It's coincidental that in both problems it's a 4, so you know. Subtract 11 from both sides. 15 minus 11 would be 4, equal 4a, and so a equal 1. So now we're going to take this, we're going to write it into the equation for all x, y. So y equal, a is 1, I don't have to write it down, x minus -4 squared plus k. Well, what's x minus -4? It's x plus 4 quantity squared plus 11. Now we can check this, okay? We can look, okay, that's our vertex is -4, 11. If I plug in x equal -6, if I substitute that in, I'm just doing a mental check. -6 plus 2, -4, or -6 plus 4 is -2. -2 squared is 4. 4 plus 11 is 15. It checks. So I can check my standard equation. Lastly, another way to find the vertex. We did a lot of this in Algebra 1. Is you can find the vertex using the formula -b over 2a. All right, so here, if I'm looking at this equation, a is equal to 4, b is equal to 24, and c is equal to 41. So let's find the vertex. Okay, so x equal opposite b over 2a. -24 over 2a, 2 times 4. So -24 divided by 8 is a -3. So in my vertex, my x is -3. To find the y, we have to substitute. So we're going to find g of 3, or g of -3. So 4 times -3 squared plus 24 times -3 plus 41. -3 squared is 9. 9 times 4, 36. 24 times -3, -72 plus 41. -36 plus 41 equal 5. So my vertex is at -3, 5. Then you would graph it the same way. You would choose 2 x values less than -4, -5, and 2x values greater than -2, -1. And I'll tell you a graph if you find a vertex this way.